This is question 26 on chemistry from section 2 of the 2019 BMAT. So the question is about this molecule diborane with the formula B2H6, and in terms of the isotopes of boron and hydrogen, we're told to assume that boron consists of 20% boron 10 and 80% boron 11, and to assume that hydrogen is purely hydrogen 1. Therefore, what is the ratio of diborane molecules with masses 26, 27 and 28? So where to begin? Well, let's firstly consider how we make up these three masses with which combinations of boron. And so the lightest one, 26, we can see will be composed of 2 boron 10s plus 6 hydrogen 1s. To make 27, we're going to need 1 boron 10 and 1 boron 11. And to make the heaviest, 28, we need just boron 11. Now, how are we going to get this ratio that we need? Well, this question is all about probabilities. And so we need to consider the combined probabilities of the two different boron atoms in this distribution in a B2H6 molecule. So maybe an easy way to represent this would be a probability tree diagram, considering firstly one of the borons and then secondly the other boron. So let's call our first boron B1. We know this can be boron 10 or boron 11, and then our second boron B2 equally can be boron 10 or boron 11. It looks like we've got 4 different outcomes, but we know 2 of these are going to be the same because we've got 3 different masses. Then we can put in our stepwise probabilities. So we know there's a 20% or a 0.2 chance of making boron 10 and a 0.8 chance of having boron 11. And then with our second boron, we know this probability distribution is going to be the same. And so at the end of the tree, let's think about what we've made. So if boron 1 is mass 10 and boron 2 is also mass 10, then we're going to have the light molecule, 26. Here, we've got 1 boron 10 and 1 boron 11, so that's boron 27. And likewise, we've got 1 boron 11, 1 boron 10 here, making 27. And here, we've got the 2 heavy atoms. And so if we need the probabilities to get this ratio of these 3 different masses, then how are we going to work these out? Firstly, what's the probability of having a molecule with mass 26? So with this, we go through the probability tree diagram. So we know there's a 0.2 chance of having boron 10. Then out of those 20% of molecules, 20% of them are going to have the second boron as boron 10. So we multiply 0.2 by 0.2, and that gives us 0.04. So that's the probability out of 1 of having a molecule weighing 26. And then what's the probability of having a 27 molecule? Now we can see that there are 2 different routes to a 27 molecule, and so we need to take both of those into account in our multiplication. And so firstly, we've got 0.2 times 0.8 going through the diagram. Then we've also got 0.8 times 0.2. So let's combine those together. We've got 2 lots of 0.2 times 0.8. Well, 2 times 8 is 16. So 0.2 times 0.8 would be 0.16. Times 2 is 0.32. And then finally, what's the probability of making the 28 molecule? So there's just one way of doing this. That's 0.8 times 0.8. 8 squared is 64, so 0.8 squared is 0.64. And just to check, do these add up to 1? Because they're all the probabilities. 64 plus 4 is 68, plus 32 is 100. So that's all okay. But the question asks us for a ratio of the 26, 27, and 28 molecules. So how do we find this? Well, we need to combine these probabilities. So we can see by inspection that if we start with 4 26 molecules, that's going to give 32 27 molecules and 64 28 molecules. That's the relative proportions. And we can simplify this ratio to make it relative to the 26 molecules. So if this was 1, we're dividing each of these by 4. 32 divided by 4 is 8, and 64 divided by 4 is 16. So our ratio that we've worked out from these probabilities of 26 to 27 to 28 molecules is 1 to 8 to 16. This is our final answer, which corresponds to an answer of E.